Right now, we are going to solve the second question. That means we wish to expand a plus b to the power 7. And then let's see how to solve it. And then do you remember we have a question in question 1, which is observe the coefficient of each term in a plus b squared and a plus b to the power 3. Are they useful in finding the expansion of a plus b to the power 7? So if you observe carefully, you can see that for the coefficient of a squared plus 2ab plus b squared is 1, 2, 1. 1, 2, and 1. And similarly, for a plus b to the power 3, the coefficients of each term are 1, 3, 3, and 1. Okay, so it may be useful for us to find out the relationship between the coefficients to the powers. If you still have no idea, let's go to a plus b to the power 4. And then when we expand it, we will consider it as a plus b squared times a plus b squared, as you can find here. And then you can solve it like this, expand it by a squared times all the things, 2ab times all the things, and b squared times all the things, and you have got 9 terms here. Then you can find the terms carefully to get this one by grouping the terms. So right now you may think more. So how can we deal with it? The table is like this. Apart from these 3 parts for a plus b squared, a plus b cubed, and a plus b to the power 4, we will consider also a plus b and add the 1 here. You may think it as a plus b to the power 0, so that it looks like a triangle. And then right now you can try to think about the numbers, because this one too is actually 1 plus 1. And then for each number, it is formed by adding the 2 numbers on top of it. And similarly for this one. Okay, so we have hit this one. So we're going to be 3 plus 3 is equal to 6. And 1 plus 3 is equal to 4. And for the leftmost and the rightmost, we only write them as 1. Because actually, you can see that for every part, for the a to the power 3 to the power 4 to the power to the square, and all the coefficients of these must be 1. So you can find a plus b to the power 5 easily. So how can you get it? It's like this. So put a 1 here. Then you write 1 plus 4 is equal to 5. And 4 plus 6 is equal to 10. 4 plus 6 is equal to 10. Okay, again, 4 plus 1 is equal to 5. And lastly, the 1 at last. So you can form a plus b to the power 5. So right now, do you have the idea of finding a plus b to the power 7? So right now, if you want to solve a plus b to the power 7, then you can use the Pascal triangle by adding the numbers until the row of the a plus b to the power 7. And after the effort, you get something like this. And it is called the Pascal triangle. In Chinese, it's called 陽輝三角形. The reason is the Western people, they got the Pascal triangle by Pascal. And for the Chinese, they also find this triangle by Mr. Yang Fei. So therefore, we have different names for them. But the meanings, they are still the same. And for this one, actually, we can use the NCR notation to show it. You can see from here. So we have 1C0 for the number 1 on the second row and 1C1 for the second term of the second row. That means A plus B. And for the A plus B to the power n, then we have NC0, NC1, NC2, and so on. And finally, it will got NCn. So therefore, lastly, we wish to find A plus B to the power 7. So we got here 1, 7, 21, 35, 35, 21, 7, and 1 at last. And the power of A is decreasing from 7, 6, 5, 4 until 0. That means that A is missing because it's A to the power 0 is gone. And the power of B is increasing. B squared, B to the power 3, B to the power 4, and so on, and until it arrives to B to the power 7. And when we want to find A plus B to the power n, then you will use the NCR notation. It is easier to express and easier to understand. And for NC0 is equal to 1, so we don't write it here. And also for the NCn. So the expression we usually like use this: A to the power n plus NC1, A to the power n minus 1 times B, and so on. And you got the final result. Okay, so therefore, we can find any power of A plus B perfect, the power, then using this method. That's the end of this lesson. See you next time.